Okay, hello guys. So today we will be trying to solve a piecewise function. Let me just write it out real quick. It's f of x, and then this is equal to 3x squared if x is less than or equal to 1. It's not a very good lesson. Oh my goodness. Let's try that one more time, shall we? There we go. X is less than or equal to 1. And then we have 2x cubed plus 1 if x is greater than 1. So first off, we want to try and find the limit of the top and the bottom. Let's do that real quick. This is as x approaches 1, because that is what the our question is asking. Our question is asking to find if this is differentiable at x equals 1, and then what the f prime of 1 is. So first off, we'll do this. 3x squared, and now if we plug 1 in there, we find that the limit is 3. The limit as x approaches 1 of 2x cubed plus 1 is also 3. So because both of these are 3, we can take the limit of this whole function, or the derivative of this whole function, because the limit exists at f of x. So if we use our rigorous formula to find f prime of x, then we can find the derivative. So if we say limit as h approaches 0 of f x plus h minus f of x all over h, and we plug this in into here, then we will get the derivative. Now, before we start though, since we're trying to find the derivative as x equals 1, then we have to choose one of these. Well, we'd have to choose one anyways, but because we have x equals 1, we know which one to choose. The top half is only applicable if x is less than or equal to 1, while the bottom half is only applicable if x is greater than 1. So since we want x equals 1, we have to use 3x squared, because that's the only function that uses x equals 1. So if we use 3x squared, then the limit as h approaches 0 is 3x plus h squared minus 3x squared. This is all over h. That is a 3, but I want a 2. There we go. Let's move this down a little. There we go. So if we keep going, we could say that the limit as h approaches 0 is 3, and then this would be x squared plus 2hx plus h squared minus 3x squared all over h. So now that we got that, we can distribute a 3 in there, and then that would be the limit as h approaches 0 of 3x squared plus 6hx plus 3h, my bad, 3h squared minus 3x squared, and that is all over h. So now that we got that, we can cancel these two right here. 3x squared minus 3x squared just equals 0. Now we have to try and get rid of this h, because since we have a 0 here, if we plugged it in, it would make the whole function undefined. And so getting rid of this is not too hard. And once we get rid of these 3x squareds, we see that we have 6hx plus 3h squared all over h. That is a very long line. Do not need it to be that long. There we go. Over h. And so we see that if we took a 3h out of this, then we could technically cross out these h's, and then we wouldn't have to worry about this one. So if we set the limit as h approaches 0 of 3h, and then right here would be 2x plus h, we can cancel these h's. So if we plug this back in, we find that we get 6x plus h. So now we can plug our 0 in because we don't have to worry about this becoming undefined anymore. So if we plug that in, we find that our derivative equals 6x. Now, since y'all have taken calc before, you could have easily just gone in here and taken our exponent, multiplied it times the coefficient, and then subtracted the exponent minus 1. That would have just given you 6x. But we were trying to be a little rigorous and really get down into the meat of this problem. So now that we have 6x, we need to find f prime of 1. And so that is 6 times 1, which we find that just equals 6. So it's not too hard of a problem. Basically what you need to remember is that every time you're given a piecewise function, always figure out if the limit exists in the top and the half and also in the whole function. And then I would recommend using the rigorous function because you can really see your steps, and if you're stuck, it helps you really figure out what it is that is going on in the problem. And then after you find the derivative, it's very simple to just plug in a number and you find whatever x or y value of x that you want. And that's how you solve a piecewise function.